Hello. Um, in this video, we will solve some fraction problems. For example, this is one circle. Now, each part, we can call that as a one part out of two. And if we have to write in a fraction part, then we can easily write it as a 1 by or 1 out of 2. 1 is numerator, 2 is denominator, and 1 is what we are intending to say, and 2 is a whole. Like whole circle has two parts, and our shaded or intended part is 1. Now, for example, similarly, if we have one circle and let's say it has approximately 5 parts. Sorry for they are not in symmetry. And let's say we shade 3 of this, we can write this as a 3 out of 5 they are shaded. Let's jump back to the first one now for a second and see, instead of having only 2, if we divide it into overall 4 parts, we can still see that its shaded parts are 2 out of 4. But we did not change any shaded area or unshaded area. That means 1 by 2 and 2 by 4, it will be symmetric, it will be equal. It means we can also write 1 by 2 equal to 2 by 4, because this is shaded, one part is shaded out of 2. If we take this line, if we take this black line, then it will be 1 out of 2. And if we take this blue line and that black line simultaneously, then we can say it has 2 shaded parts out of 4, which will be 2 out of 4. It means 1 by 2 is equal to 2 by 4. We can see, because 1 by 2, 1 out of 2 pieces, 2 out of 4, out of overall 4 pieces, 2 are shaded. It means, and 2 by 4 is back again to 1 by 2, that is equal to 1 by 2. So in simplified form, if we say that okay, I have 1 by 2 and I divide each part by 2 with this line, that will make it 2 out by 2 and will give us 2 by 4. That is one question solution. If we come back to this one, for example, and this is 3 by 5. And now if we further divide each by 1, just like we did there, let's say this one, this one, this one, this one, this one. If we only take those blue lines, which then we can see it as 3 by 5. And if we take blue and black simultaneously, then we can see it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out overall parts. Out of 10, there are how many shaded? 1, 2, 3, 4, 5, 6. 6 out of 10 they are shaded. Well, we did not change any shaded or unshaded part. They are purely same. We only changed their divided each part into half further. It means 6 by 10 and 3 by 5 are equivalent. They are equal, not only equivalent, sorry. Similarly, if you want to divide each part further, we can further multiply this one with 2 by 2, and that will give 12 out of 20 if we further divide each part into 2. Without changing shaded region, that is how our parts keep changing. Similarly, if we take that another question, for example, 5 by 9, let's say, how to represent that. Let's say we have one square this time. Sorry for poor handwriting. And it has overall 9. And 9 overall parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, just to remember. And if we shade it, let's say we shade first 5. Now, for example, if I'm shading only 1, we can write it. How many are shaded? 1 out of 9. In fraction, it will be 1 out of 9. And if we shade second as well, it will make it 2 out of 9, because overall there are 9. That's what we are having denominator. 2 parts are shaded, that is what we are writing it, so 2 out of 9. And if we include third one, will become 3 by 9, and so on. And let's say we shade up to 5. So we can write it that 5 out of 9 parts are shaded. But further, without changing shaded area, if we divide each part into half, let's say I draw this line. Now it has overall 18 parts, 9 below this center line and 9 above center line. 5 are shaded in overall this way, and now 5 are shaded below center line and 5 are above center line. That means 10 out of 18 are shaded. Now it has 18 parts, 9 below and 9 above. Well, we see we did not change any shaded part. We only drew a new line, which makes it equal, because shaded region is equal what was before we draw this line and what is after that, which means 5 by 9 is equal to 10 by 18, or it is simply equal to one old saying is like if we multiply and divide numerator and denominator with the same number, fraction remains same. For example, if we have 5 by 9 in this example, and if we multiply numerator and denominator by 2 by 2, it will make it 10, and in denominator it will make 18. Similarly, if we further divide this bottom part into half and top part into further half, then it will be further down, multiply by 2 and 2 each part. That will be 20 over 36. right? So it means 5 by 9 is equal to 10 by 18 is equal to 20 over 36. We'll do 3 more questions and then we'll leave this. Now, for example, if we have another question, let's say we have another rectangle here, and we have overall 8 parts of this. This is 1, 2, 3, 4, 5, 6, 7, and 8. Out of those 8, if we share the first 3 parts, can we write it as a 3 parts are shaded out of whole? Whole has 8 parts. And if we divide this, let's say instead of dividing into half, if we divide into 3 parts, let's say 1 is here and 1 is here. That means simply we have made now overall 3 times we increased its parts, which gives us overall 20 boxes, 8 here, 8 here, and 8 here. It means that is overall it is 24, 3 times of 8. How many are shaded? 3 were here, 3 here, and 3 are here, out of 9 out of 24. Without changing shaded part, we increased number of shaded and unshaded parts by dividing whole diagram, whole shape into equal parts. That means basically we increased parts by 3, all parts, which is equivalent to multiplying and dividing our first fraction with 3, which will give equal 3 into 3, 9, 3 into 8, 24, which is same what we found here. That means if we are dividing a fraction into equal parts, that does not affect our shaded area, the resultant fraction will be equal to our old fraction. Resultant fraction is 9 over 24. Our first fraction was 3 by 8. But in mapping, that is basically 9 by 24. And we can say that 3 by 8 is equal to 9 by 24. Or similarly, if we had divided this into, let's say, instead of increasing 3 times, we had increased it by 5 times, then it would have been multiplying and dividing by 5, and it would have been 15 over 24. That is another hypothetical. Yeah, and that's all about fractions. And these are called proper fractions because their numerator is always smaller than denominator. That's why these are called proper fractions. And we can map those on our boards. Thank you.